Example number 2, x is equal to 2. This changes a little bit. If I write down 2 cosine of t and y equals 2 sine of t, and again we say 0 is less than or equal to t is less than or equal to pi, 2 pi, and I want to find the Cartesian equation. So if your parents ask you what you learned today, you could say, well, it's nothing really. Mr. Adams told us or showed us how to take basic parametric equations and convert them to Cartesian equations, but other than that, not much. So what we want to do, so then x is equal to 2 cosine of t. Y is equal to 2 times sine of t. And so we'll just plug in some random values, the same ones that we used before, and 3 pi over 2. So this one would be 2 cosine of 0. Now normally cosine of 0 is 1, but when we multiply it by 2, what do we get? 2, right? And 2 times sine of 0, if you plug that in your calculator, normally sine of 0 is 0. And 2 times 0 gives us 0. So we've got 2 comma 0. So now if we were to graph this, this is just like our other equation, except now we're at 2 comma 0. So if I say 2 times cosine of pi over 2, what would that be? Well, cosine of pi over 2 is 0 times 2 is 0. And then if I say 2 times sine of pi over 2, that would be 2. So again, we go 1, 2, right? If I say 2 cosine of pi, normally cosine of pi is -1, but -1 times 2 is -2. And then 2 times sine of pi, normally that's 0, 0 times 2 is 0. So I've got this point here. Two comma 0. And then this point is 0 comma 2. And then lastly, if I say 2 cosine of 3 pi over 2, that's 0 times 2, right? And then 2 sine of 3 pi over 2 is equal to -2. Oh, I wrote that down wrong. It's 0 comma -2. So again, I have a circle. Now what do you notice about my circle?
Bigger, larger.
The radius is what?
Wider.
So the center of my circle is 0 comma 0, but my radius is 2. Okay? All right. Now let's write the Cartesian equation. So now if I write the Cartesian equation, again, let's remember what we're trying to do. We've got 2 cosine of t is x, and y is equal to sine of t, 2 sine of t, or almost forgot the 2. And we have some information that the center is 0, 0, and that the radius is equal to 2. So normally we would say x minus h squared plus y minus k squared is equal to r squared. Remember that the center of the circle, right, because this is the center of the circle, is my h comma k. So if I plug that in, I should get for my Cartesian plane x squared y squared equals 2 squared, or 4. Now that's what it should look like. X squared plus y squared equals 4, but I need to prove that algebraically. Okay, so I'm going to use a different color marker because this is what we're supposed to be doing according to the textbook. We're going to say that x squared plus y squared should equal 4. So I'm going to say 2 cosine, I'm going to substitute in my parametric equation for x. So I'm going to say 2 cosine of t squared plus 2 sine of t squared should equal 4. Okay, so far so good. Well, when I square that, really what I get is I get 4, right? Cosine of t plus 4 sine of t squared equals 4. And so I could factor this out, right? So I want to make the left-hand side equal the right-hand side. So if I factor out the 4, I get 4 cosine squared of t plus sine of t equals 4, right? Can I make the left-hand side equal the right-hand side? Yes, Mr. Adams, because Mr. Adams so eloquently explained that this is equal to 1. So I'm going to say 4 times 1 does in fact equal 4. True, good job. So this is the Cartesian equation. And we've proven it. You're welcome.